Hello students, welcome back to my YouTube channel. This is Kashima Soni and today we are going to start the next topic, that is the last topic of mass analyzer, that includes time of flight mass analyzer. Okay, so previously we have discussed the introductory portion, the ionization methods, the 4 ionization methods that we have discussed, the 3 mass analyzer techniques that we have discussed so far in the series of mass spectrometry. So if you have not checked any of the videos, I have mentioned all the links in the description box. Check that first, then switch to this part of the video for your better understanding. Okay, so without wasting any more time, let's proceed further to the last mass analyzer, that is your time of flight mass analyzer, and that is over here. Okay, so this is how it is, your mass analyzer. Let me just get back to previous slide. Okay, so what is happening? See, your time of flight mass analyzer, it is actually based on the simple idea that velocities of two ions created at the same instant with same kinetic energy will vary depending upon the mass of the ion. Lighter ion will be having higher velocity. Okay, so what they are saying, अगर आपके पास क्या है कि आपके पास किन्हीं भी दो आयन्स की सेम वेलोसिटी है, they are created at the same instant, have with same kinetic energy. इस केस में क्या होगा, जो lighter ion होंगे, they are going to have high velocity. Okay, so if these ions are traveling through their mass spectrometer's detector, the faster, that means your lighter ion will strike the detector first. Okay, so you can see this is your sample holder, and after passing to the laser over here, what is happening? The ion having lighter nuclei, or lighter ion, that is your lighter mass, that is M3 over here, it is going to reach your detector first. Okay, so M1 is having the highest size, the largest size over here, and it is not going to reach your detector first. Your M3 is going to reach the detector first because it is your lighter ion having higher velocity. Okay, so that is one thing over here. Proceeding further, so now you can see over here, if your kinetic energy of the ion accelerated through the electric potential V, you can write it as such, like mv squared by 2, that is your kinetic energy, is equal to your charge multiplied by potential. So that is similar, this particular equation is similar that we have discussed in the magnetic sector mass analyzer. Okay, so if you have not checked the video, the link is mentioned over here, just go through it, check that first, and then switch to this part of the series. Okay, and now over here you can see your velocity is represented by speed by time, and over here they have shown that your velocity is actually velocity of the ion is that length of flight path L, that is this over here that we have mentioned, V is equal to L, that is L, length of flight of path L, and T is the time it takes for an ion to travel over the distance, and that is your V. V is equal to L divisible by T. Okay, that is your velocity. So you can put the velocity value in this particular equation 1, and you'll get the equation ml square divided by 2t square is equal to ev. So from here you can easily write down the value of your m by z like that. So how you are going to write the value of m by z? Now you can see m by z now over here, that is m by z is nothing but z is your charge only, E. So I have mentioned over here z, that is your E only. Okay, so that is one thing. So that is how you can mention over here, that is your m by E or m by z is equal to 2 Vt square is equal to divisible by L square. So that is the formula of your mass by charge, and from here you can also detect your T value also if the rest of the values are being provided to you. Okay, so that is how you are going to get the value of mass by charge using that particular formula. So what is happening? Your time of flight mass analyzer, actually it requires very fast electronics to accurately measure the ion flight time. Okay, so if you have to for example detect or accurately measure the ion flight time, for example in sub microseconds, so your TOF, it should be of very fast electronics. Okay, and furthermore the ions in your this particular system must be created in short well defined pulses, so that the ions, they all start their journey toward the detector at the same moment. Okay, that is one thing. So the first requirement explains why your TOF instrument did not become widely used until the 80s and 90s, when suitable circuitry become cost effective. Okay, so that is one thing. The about your TOF. Okay, so the last requirement is perfectly suited for MALDI ionization technique and MALDI TOF mass spectrometers. They're actually found to be of very wide use in your biomolecules. So that is one theoretical portion to be discussed, and you can consider the book Pavia for the same. And we'll be taking about other part of this particular time of flight mass analyzer. That includes the disadvantages, that is, it is inherently of your low resolution. Okay, so that is one thing, and the mass resolution of your TOF is actually proportional to the ion flight time. Okay, so that you can see from here also, your mass is directly proportional to your ion flight time. Okay, correct. So using long drift tubes, will be going to increase resolution. So you know that your TOF analyzer is having the disadvantage of a low resolution. So if you want to increase the resolution, you can use the drift tubes that are longer in size. Okay, so flight tubes of few meters long are commonly used in high-end instruments. What is the modification that increases resolution is your ion reflector. That is the modification in your TOF instruments. What is happening? This ion reflector is nothing but an electric field behind the free drift region of spectrometer that actually behave as an ion mirror. Now what is happening via this ion mirror? This reflector is able to refocus ion of slightly different kinetic energy, and if set it at small angle, it sends the ion on the path back towards the original ion source, which is leading to the doubling of this ion flight time as well. So that is one thing happening over here. So yeah, that is all about your time of flight mass analyzer. Okay, so I'll be stopping my video over here only, and we have completed the topic mass analyzer in your chapter mass spectrometry. Next is what we are going to discuss about your molecular ion peaks, your isotopic ion peaks, nitrogen rule, Stevenson's rule, and everything in this particular chapter. We are going to take up the fragmentation techniques. So there are going to be many videos coming in this particular series. So which is why I'm requesting you to just check the all the videos that I'm uploading in this particular series for your better understanding of the chapter. Okay, so yeah, that's all about it. I'm stopping my video over here only. So thank you for watching. Do like, comment, share the link, subscribe the channel, and do not forget to press the bell icon for latest updates. Thank you.